Okay, in this video we're going to have a look at question 13 from the WJC Additional Maths paper from June 2014. So we have the following equations represent straight lines. We have 1, 2, 3, 4, 5 different straight lines. Which equations represent lines that are parallel? You must explain how you know that these lines are parallel. So the easiest way to check whether lines are parallel is to put them in y equals mx plus c form. So make y the subject. And then check the gradients, because any pair of parallel lines will have the same gradient. So let's take each equation in turn. 2x plus 4y equals 7. So I'm going to subtract the 2x. Oops, should be a y there. And then divide by 4. So y equals 7 quarters minus 2x over 4 is going to become x over 2. So if I take the first equation, 2x plus 4y equals 7, let's make 4y the subject first, so I'm going to take off the 2x. And then I'm going to divide both sides by 4. Now, rather than writing that as a division, I'm going to write that as a quarter of 7 minus 2x. And that kind of shows that I can multiply through by the quarter, which gives me 7 over 4. And minus, well, 2 quarters is a half. So minus a half x. So the gradient will be negative a half. So if I do that for each of them, so 2x plus 5y equals 7. So if I do it a little bit faster, I get y equals, so it's going to be, I start with a 7, I'm going to take off the 2x, and then I'm going to divide everything by 5. So I get 7 over 5, and minus 2/5 x. So my gradient is negative 2/5, so they're not parallel. Let's take x plus 2y equals 7. If I rearrange this, I'm going to start by taking off x, so 7 minus x, and then I'm going to divide everything by 2. That will give me 7 over 2 minus a half x. Okay, I now have parallel lines. So we got those who are parallel because they have the same gradient. But we just have to check the other two. I'm running out of room, so I'm just going to do them up here. So 4x minus 2y equals 7. Well, in this case, we've got negative 2y. So I'm going to start by adding 2y to both sides. So I'm going to get it on the right. And I'll take off the 7. So I get 4x minus 7. So my y is going to be, divide everything by 2. 2x minus 7 over 2, in which case the gradient is 2. And the last one, 2x minus 4y equals 7. Doing it a similar way, I get 2x minus 7 equals 4y, and then dividing everything by 4 will give me a half x minus 7 over 4. So that would be the gradient. So the two that have the same gradient are going to be this one and this one. So we can say 2x plus 4y equals 7 and x plus 2y equals 7 are parallel, as they have the same gradient. Okay, part B. Write down any two of the equations that represents lines that are perpendicular. Okay, so it's perpendicular this time, not parallel. There's parallel in the first one. So, in order for lines to be perpendicular, so let's put my reason first. So perpendicular if one gradient is the negative reciprocal of the other. Another way to think about this is if the two gradients multiply to give -1, then that will happen. So looking at the ones that we've got, the ones that will multiply to give -1 will be, okay, so we have a choice. It has to be this one, but it could either pair with either one of those two, and either of the two parallel lines. Okay, so we'll have 4x minus 2y equals 7. Is perpendicular to 2x plus 4y equals 7. And you only have to give one, but I may as well give them both. So, and x plus 2y equals 7.